In 1974, a group of scientists were handed a string of digits. They were told it was a message from space. They had a deadline to decode it. They couldn't do it in time. But they were all of them deceived. The string of digits wasn't received. It was sent from Earth. It's the actual message that was beamed into space in November 1974 to commemorate the upgrade of the Arecibo Observatory in Puerto Rico. For 53 years, Arecibo held the record for the largest single-aperture telescope on Earth, a dish built into a natural sinkhole in the ground. To mark the new transmitter, astronomers Frank Drake and Carl Sagan designed a space message. It would have no words, no pre-shared language, nothing a listener would need to already know in order to understand. So how could a message with no words still be readable? Because of one number, 1679, the length of the message. 1679 is a semi-prime, a product of exactly two prime numbers, 23 and 73. 1679 can only be visualized two ways, 73 rows wide and 23 high, or 73 high and 23 wide. 73 high and 23 wide shows an infographic. Flip the grid the other way and the picture dissolves into noise. What does the picture actually show once it has been decoded? It begins with the numbers 1 through 10, written in binary, one number per column, read vertically from top to bottom. The top bit is the most significant digit. 1 through 7 each fit in a single column, 3 bits tall. 8, 9 and 10 need a fourth bit so they don't fit in one column. Their binary code spills into a second adjacent column to the right. That's a deliberate design choice. It demonstrates to a reader that a number too large for one column simply continues over into the next one. The bottom row of the block isn't part of any number's value. It's a separate row of single marker dots, one under each column that starts a new number. The marker row anchors where each number's count begins. After the numbers come the elements, comprising the 5 building blocks of DNA: hydrogen, carbon, nitrogen, oxygen and phosphorus. Their atomic numbers are readable because the reader now knows how to read numbers. Below those DNA building blocks, the chemical formula for compounds that make up the DNA's own nucleotides. Then the estimated count of nucleotides in the human genome, beside a graphic of the double helix itself. A human figure follows, average height marked beside it, 5'9", and the population of Earth at the time, around 4.3 billion. Below the figure is our solar system, the Sun on the left with the third planet out of line, pointing to the human shape above. Lastly, a sketch of the Arecibo dish itself and the width of the antenna that sent the whole message. 7 info blocks, one continuous picture, no caption anywhere. Where did they aim the message? It was aimed at M13, the great cluster in Hercules, a tight ball of roughly 300,000 stars, 25,000 light years away. Drake picked it for the odds. More stars packed into one patch of sky means more chances one of them has a planet and a listener. But the message was theoretical. It never really had a shot at landing. First problem, M13 isn't standing still. Over the 25,000 years the signal takes to arrive, it will have drifted away from the exact point that Arecibo was aiming at. By the time the message gets there, the target won't be there anymore. Second problem, Arecibo itself is fixed into its natural sinkhole. Earth's own rotation during the 3 minutes it took to send swept the message across an arc 25,000 years in the making. The scientists in the room weren't failing to read a message received. They were staring at a diagram built to prove the question could be asked, not to guarantee anyone would ever pick it up.